And I'll do another one from scratch, right? But this one was a little tricky because it doesn't show it on this graph. But if you look at the solution region, right, there are two corner points really close together here in this section right here, which is more visible when you look at the graph here. Let me see if I can zoom in a little bit more and change the brightness a little bit. Is that? Do you see the two corner points? Like there's actually where the purple and the blue meet. And then there's another one right there where this purple line meets the black line, right? So this actually, you have to be very careful in finding your corner points there. And I show you on the video how I do that, right? So if you want to be super prepared for something that is potentially higher up there on the difficulty level, this example would have been it, right? So I'll do more where it's not as busy. Okay, so again, watch December 14th video. I actually graph this, right? I don't know if you right now just want to take a picture and add it to your notes later, but I will actually start one from scratch. I won't talk about this one anymore. Notice that if it says a potential solution, I picked 1, 10, right? Somewhere in here. And so that in this case means producing 1 car and 10 vans, right? It's not just a point. X represents the number of cars, Y is the number of vans we've produced, right? And this meets all of the requirements that we came up with, right? So every restriction kind of gets rid of certain possibilities, right? The more restrictions you have, and then you end up with just your solution region. And I hope that now makes sense why I used reverse shading, right? Because what's left is clearly visible, right? And that's why I did that. Okay, so let's keep going. I will ask you to, this was actually, the question that I'm going to do next is on page 48. You should have seen this before if you did your homework. And remember, we are writing our quiz tomorrow, so that'll have this kind of stuff up to this point will be on there, right? Second period, right? So that's good. For each of the following graph, then determine the POIs, right? So Spence is a DJ and is often is hired to play at birthday parties and weddings, right? A birthday usually takes 3 hours, while a wedding takes 5 hours of his time, including setup and cleanup, right? He earns a flat fee of $450 for a birthday and $625 for a wedding. So these are just facts. They're not telling us any kind of restriction, right? This is on page 48. Here come the restrictions, right? And I will try to do this, right? I think that these aren't the easiest ones to do. So I will try to say, hey, restrictions, here they are, right? As much as I can. Some of the ACs won't, right? But Spence has at most 40 hours per week available right there. The at most should have indicated, right? But I'm going to do at most 40 hours per week available. Okay. And let's first define our variables up here. We'll let X be something, Y be something. And yes, you should think that it's birthdays and weddings, right? Birthdays, weddings. And then you have to ask yourself, would it be hours? Would it be number of? What do you think makes most sense in this scenario? Because the hours are here, right? They're telling you how many hours each one of them will take. So this would be number of birthdays, number of weddings, right? And don't forget about a good old implicit constraint. And you know what I'm going to do? to be efficient, I'm going to write out my inequalities like this here, so we can do the work right under them. Okay. So for this one right here, let's call this IQ1, right? This is my first inequality. At most 40 hours per week available. So what that is saying that if it takes 3 hours to perform a birthday and 5 to perform a wedding, that has to be less than or equal to 40. Okay? That has to be less than or equal to 40. That's what that statement is saying right there. Next, Spence would like to earn at least $2,300 a week. Again, right? A minimum of, or at least $2,300, right? So we're going to say, okay, how would this work? Well, there are dollar amounts way up here. Dollars would match dollars. So if it's 450 for a birthday, 625 for a wedding, you want that combination to be greater than $2,300. Okay, so you've got that taken care of. Spence would like to DJ at most 9 events per week combined. At most 9 events. And we'll say combined. It doesn't say 9 birthdays or at least 9 weddings. It says combined, right? So we will say X plus Y at most, right? So that would indicate that, right, the combination of birthdays and weddings would have to be less than or equal to 9. We'd like to DJ a minimum of 2 weddings per week. Let me give it another color for highlighting. I don't know if you notice, minimum of 2 weddings per week, right? So that is specifically just to one variable. You're gonna like these ones because they're easy to graph. So this is just talking about weddings. So Y, which way would that inequality go? Minimum of 2 weddings. So you want the number of weddings to be greater than or equal to 2. That's what that would look like. And I'm going to say IQ2, IQ3, IQ4. Okay, so this is 1, 2, 3, 4. And you will notice that if you have a lot of inequalities, that 1 or 2 of them will be pretty easy to do, easy to graph. Not always, but quite often. Let's start with this one. It's already rewritten and everything. Solid, true is above. Where are we going to shade? Below, right? Reverse shading. Done. Right? I'm going to box this in because it's all done. Nothing else. It's a horizontal line, right? Just a horizontal boundary line. Easy to do. I'm going to do this one next. Do you remember how this is going to work? I think I rushed the other one and I don't want to do that. I take full responsibility for what happened yesterday. Right? So this is 9, 0. Y would be 9, 0, 9. But if you just have X and Y and a number, that number is going to be your X-intercept and it's also going to be your Y-intercept. That's special about them, right? And so rewrite it quickly. Y is less than or equal to negative X plus 9. Solid, true is now what? Actually, make sure this is on your study sheet, guys. This part, like what happens when it's Y less than? Where is the true region? And it's below, right? And we're going to shade above. That's also good to have. If you go way back, I gave you a little chart where that should be in, right? I gave you a chart, I'm pretty sure. So make sure you have that. And then let's tackle the harder ones. Okay? I'm just going to pause right here. Go ahead and find the intercepts and rewrite this. can go ahead and enter the equations already into your y1 and so forth. There they are. And rewriting it. All right. Notice in particular, this one right here. Notice that I do get the decimal for the intercept, but then when I enter it into my calculator, I leave it, right? That way you use all decimals. This is just to help you graph, right? So go ahead and enter that. And I always put the coefficients in brackets, or if there's a fraction in general, I'll just put the brackets in there. That's negative x plus 9 and 2. Right. So you might have a vertical line. In this case, it's a horizontal line. Just keep that in mind, right? And I'm just going to try. I'm looking at all my x-intercepts here. And the greatest one is 13. So I'm guessing if I go to my window, I don't care so much about the negative x values, but the max, I'm going to go to 20 or 15 or something like that. And the y-intercepts, there's 8, 9, right? Those are, so if I go up to 15 for my y max, that'll do the trick. And that also gives you a pretty good idea of what your window will look like, right? What window to consider. So that's what it's supposed to look like when you're all said and done. So let's go ahead and graph it. Grab a ruler, if you have one. And I'm going to stick to this corner because I'm going to find the POIs and all that later. So something like this. And we know that based on our variables up there that we defined, this is the number of weddings. And this is the number of birthdays. Got that out of the way. And I think I'm going to go up to 15 along the x-axis. 1, 2, 4, 6, 8, 10, 12, 14, 16. Right? That'll do the trick. And then going up the y, I'm going all the way up to 9, right? My largest y-intercept is 9, so if I go to 10, I'm fine there. So 2, 4, 6, 8, 10. Do one more for. So it's a good scale. Again, you decide as long as it's consistent. X can have its own scale, Y can have its own scale. You can go up by 10 here, by 5 there if you'd like, as long as you're consistent. And then plot it, right? I'm going to start from the left here. So 13, this would be 14 right here, so 13.3 is right about there. 0.8 is right there. Connect them. And this is 3x plus 5y is less than or equal to 40. And you can sometimes do arrows, go take an arrow out of the graph if you like. Okay. 511, this would be 6. This is 5, so 511 is just over to the right. 0.368 would be right about there. You graph that. And here I'm going to do one of those, like going out of it. And it doesn't matter how you do it, this is not a pretty one. So there's that one. And then there's 0.9, this would be 10 here, right? So 0.9 is right there. And 9.0 is right here. X plus y is less than or equal to 9. And there's the y is equal to 2. So that's this one right here. And I am going to cross through some of my labeling. That is fine. Right? This line gets an arrowhead. This is the boundary line for that inequality right there. I'm going to zoom into that graph right there a bit. There we go. Start shading. So the very first one we graphed is this one. So if you want to make sure you got it right, I'm gonna say that that label belongs to that line, and it says to shade above that one. So I don't know if I'm giving you some strategies because I know where this goes. I know where it ends, right? But I don't know if you just want to do like a light one like that, right? You shade that a little bit, and then you check your other line, which is this one. It says to shade below, right? You just give it a little, just a little below there. Okay, that's all gone. And the third one, the 9.0, that one says to shade above, so you would be shading above that one. Right? So this is all gone. This is all gone above that one. And the horizontal says to shade below that one, right? So you kind of have a pretty good idea that this is your solution region. I don't know if you want to do that before you fully commit to this, but whatever works for you, okay? Because sometimes you do this and there will, because you made a mistake higher up, you might not have a solution region. Okay, so then you find out, wait a minute, right? If I do it this way, everything is shaded, so everything is false. So everything there's gone. I'm going to go below the horizontal. Below this one. So there's my solution region. Just make sure you label it. And And with this one in particular, you've got 1, 2. These ones we already know, right? 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5 corner points. Yikes, right? And that's why I made you practice that at the very beginning of this unit. So let's go ahead and find those. So I'm going to go POIs. Let's do the ones we can just read. These two we can read off of the graph. So this one here is 0.368. 3.68. This one up here is 0.8. Okay. Yeah. There's a problem with this one. If it's discrete data, number of things, right? We need to round. So we're going to go 0.4. Discrete. And now we need to find the remaining 3, right? Using the calculator. So grab your calculator. I'm actually, I want you to try it before I give you the answer. Try to find these 3 because it's not as easy as it looks, right? I'm going to pause here for a bit. I'm going to focus on the blue. For me, it's the blue line. It might be a different color for you, right? Because I change the color sometimes. So I hit enter on the blue line, but I want the next one to be on the black line. See, I keep going up and down arrow until I get to the 2 lines that I want to find the intersections for. So that one is 2.5, 6.5. Did you get that one? Yeah, okay. The next one I'm going to focus on is this one here. These 2, in fact. So I can trace 5. And I'm going to jump to the red line and then to the purple. Right now I'm on the purple there. And that is 2.332. Just write them down for now. And then one more time so I can trace 5. I'm going to jump to the purple, maybe. Yeah. Go closer to that one. Enter. Jump to the black line. And that's 7.2. There you have your corner points of intersection, and then we just make sure we round them accordingly. 3.7. This would be 2.2. So just round up or down. Sorry, this one doesn't need to be rounded. So your corner points are essentially these ones, right? These are the ones we would consider moving forward. Okay. So just that one extra step. So if I ever ask you, it's like, hey, there's a word problem and Johnny got 2.5, 6.5, why is it not acceptable? Well, based on the variables, it's discrete. You need to have whole numbers. So this would be an acceptable answer, right? What else am I missing here? I feel like I'm missing. Oh, yeah. State a possible solution. So if it ever asks you a possible solution, you could actually pick one of the corner points. Or you just kind of say, okay, 4, 4, right? 4, 4 would definitely be it, right? That would be an option. Having 4 DJing, 4 birthday parties, and 4 weddings would do the trick, right? If you were to plug them into all the inequalities above, it would be true for all of them. That's also what you're saying. Okay. So it's a headache, guys. It's a headache. I won't take that away. Some of you might dread this unit, but we're almost done. So what I'm going to do next is I'm going to give you an AC. This is specifically talking about type A, type B individually. So you get 1 mark for each of those, and then 1 mark for the restriction on the hours, right? Because you notice that there's a maximum of 180 hours. So that's when you use the coefficients, I should say, 3 and 2. Right, because it tells you that type B requires 2 hours, type A 3 hours. So 1 mark for each of these, right? So if you have any one of them wrong, just go -1 or -2, right? If you have two mistakes, and there we go with that. Graphing. When it comes to graphing, technically, so the inequalities stand alone, 3, 1 for each. When you need to graph, that's when you need to do all this extra work we usually do. I will not give you any marks for this part because it's pretty straightforward. I will give you a mark for figuring out the intercepts for this one. So a mark, so it's 60, 0, 0, 90. And another mark for rewriting it. Okay, so if you have it like this, if you didn't, if you have 180 at the back here, I would say a full mark deduction today. Okay, so it should be 90, it should jive, right? So far 2 marks for the graphing part, and we'll give you 3 marks for this part here for the actual sketching of it. So notice that I went up by 10 and by 10. So if you have a consistent scale, you would not lose marks. If you're missing labels, take off half, right? And then I need to graph now, right? So I waited until, so this X50 is right here. Okay, label it. And then the Y60 is here. Those ones are nice and quick, right, to do. And then the diagonal is 60, 0, it's right here, and 0, 90, which is way up here for me, right? So let's line that up and go with it. And this one is 3x plus 2y less than or equal to 180. So if you missed any one of the other labels, take off another half, right? And then the shading part. This would be worth a full mark doing it correctly. So I'm going to shade above for the diagonal. So I'm going to do that first. Fast forward. Okay, anyways, I'm trying to make it quick here. The horizontal is also above. Told myself that. See? Speedy Gonzalez there. And then, ooh, what did I do here? For the vertical, the true is to the left, so I have to shade right, not above, right? And so I have to shade this part here. So that's all gone, everything around it is gone. So this is your solution region. If you didn't label it, take off half, right? And then the corner points are actually, so there's 1, 2, 3, 4, and don't forget about your good old 0, 0, right? It's technically surrounding the solution region. So 3 marks for this part for having done so. I told you what to take off for. And obviously, if you made a mistake up here, I would honor it, right? Your graph would still be correct in my opinion, right? So keep that in mind. So this would be D, right? And for E, the POIs, let's do the ones we can read. So on my key, you will often see I'm just reading them off, right? So 0, 0, 0, 60, and 50, 0. I would give you half a mark for each of them, right? So this is 1.5 marks for that. If you didn't have 0, 0, take off half, right? And then for the ones I need a calculator for would be this one and that one. Do you remember how to do a vertical line? You should have that on your study sheet, right? This is how you do verticals. So you have 9 nines, or Jalen, go see Jalen, he has another way of doing it. X minus 50. So you got to do the opposite of whatever you're trying to graph. If you are trying to graph the negative 50 line, you would go plus 50, right? So that's the key here for this to work. And I'm going to graph it. So I can trace 5. I'm going to find this one down here first. So you are on the blue line, guys. So just hit enter. And then jump to the black line there. And this 50, 15. Perfect. That's worth a full mark. Second trace 5. I'm going to jump to the red, right? Hit enter. and you jump on the diagonal automatically. In my case, so that's 2060. That's another mark. So what do we do with the half? What do we do with the half? This is what we're going to do. Let's go back to the top here. And so between 1 and, so A and B, that's just going to be worth 1.5, because quite frankly, the implicit constraint is very easy to do. Right? So we're just, instead of making that 2, we'll make that 1.5 between A and B. Right? So that's going to take care of that half that we just created here. So the ones you can read, I usually just give half a mark. The ones you need your calculator for, I give 1 mark for each one of those. Okay. So what are we at here? 3 for the graph, right? So 3, 4, 5, 6.5, 8 with the top here, plus 3, that would be 11, 12, 13. So this page is 13, I should say. This page is 13. The backside we are yet to do, right? We're going to have just enough time to get the backside done because we're not graphing, right? So let's say you completely missed the boat here. I will look at it and I will adjust your mark. You're not going to get 0. There's no way you're going to get 0 if you did quite a bit of work. Okay, just let me know. So the backside, Stephanie estimates that she burns 600 calories jogging. That's just a fact, right? 600 for 1 hour, 400 when cycling for 1 hour, right? She wants to burn at least 40. There's inequality right there. Burn at least 4,800 calories and spend a maximum of 10 hours exercising. Find the corner points of the solution region, blah, blah, blah. We're not going to do that. X would be number of hours jogging. Y would be number of hours cycling. And then XY would be greater than equal to. So we're going to give you 1 mark for this part right there. That should have been there. It's hours. It's not just jogging or cycling. What is it? In this case, it's hours. That's the only one that makes sense. So we would say, let's talk about calories here. Nobody wants to talk about calories. 400, right? You burn this much for that. Every hour you jog, every hour you cycle, and you want that to be at least 4,800 calories, right? So calories, 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 right? And then spend a maximum of 10 hours would be like this, right? Because the hours you combine, you spend on either one of them should be less than or equal to 10. So 1 mark for each. So 3 for this. So 3 and 13 would be 16. Anybody do the bonus? You want to know what the bonus is? Maybe. The length of the pen must be greater than the width. So X is length, Y is width. That's how I would do it. X, Y obviously have to be greater than 0. The length must be greater than the width. So it doesn't matter how you do it, but the length must be greater than the width. So the open mouth must be towards the X, okay? That's one of them. You see here. And so we got that one taken care of. The perimeter can be no more than 120 meters. What's perimeter? 2x plus 2y has to be less than or equal to 120, because that's how the perimeter is found, right? Distance around. And the area must be at least 280 square meters. Sorry about that. That's square meters. Something went wrong. So x times y is greater than or equal to 280. If you have all of them, you get plus 2. If you have one of them, I give you half. That's the deal, right? If you have 2, I would give you 1. So half a mark for 1, 1 mark, bonus mark for 2, and then if you have all 3, inequalities, I give you a bonus of 2. So we are out of 16 plus the 2, right? So you can technically score 18 out of 16 provided that you got everything right. So have a good day, guys. Just leave it on your desk. I'll get it. Yeah. You know the homework, right? I posted the key already.